The main portion of this presentation is going to be about the seismology of a hollow planet. But before we get into that, I will be giving you some background information about the hollow earth theory. While I am speaking, I will be putting up slides showing various diagrams and information contained in my book. The slides you will see prior to the seismology presentation will not necessarily relate to the things I am talking about. It is merely to give you an idea of some of the photographs and diagrams in my book. There is simply too much for us to discuss in this hour. So the main part of this presentation will only cover one chapter out of the 19 chapters of my book. Let me tell you how I first became interested in the hollow earth theory. Back in the 1970s, two scientists from the Soviet Academy of Sciences proposed a theory that the moon might be hollow. An American author by the name of Don Wilson then wrote a book based on this idea. It was called Our Mysterious Spaceship Moon. One of the more interesting things mentioned in that book was the Apollo 12 seismic experiment. Apollo 12 placed the first seismometer on an alien world. NASA did not expect many moonquakes. They expected the moon to be seismically dead. To ensure some kind of seismic results, they deliberately crashed part of a rocket into the moon. When they did this, the results astounded them. The moon's behavior was quite unexpected. It rang like a bell for almost an hour. Quotes from the scientists of the time are quite interesting. Science News, in its 1970 yearbook, went on to suggest that maybe the moon is hollow. It stated the following: during the first day or two after the event, many researchers were reluctant even to try to devise a lunar model that would fit the strange phenomenon. Some such models would have made for a rather bizarre moon, such as a hollow titanium ball, said Captain Shearer, which is highly unlikely. Two Russian scientists then wrote a paper entitled, Is the Moon the Creation of Intelligence? It was published in the Russian journal Sputnik. They suggested the moon had been created by aliens and put into orbit around the Earth. I never forgot the hollow moon theory. It made me open to the idea that the Earth or other planets might also be hollow. My interest in the hollow Earth theory only began in the early 1990s, when internet came to South Africa, and I started discussing the idea with Americans. I then learnt of another book, this time by an American named Marshall Gardner. He revived the hollow earth idea in 1913. He wasn't a scientist. Instead, he seemed to be something of an inventor and perhaps even an engineer. He wrote a book entitled A Journey to the Earth's Interior. Marshall Gardner wrote a great deal about the Arctic regions and the idea that there was a gigantic hole covering all of the Arctic, which led into the Earth's interior. He tried to show that hot air came from the north instead of cold air. He also cited evidence of animals which traveled north for winter instead of south. I am by profession a software developer and an IT consultant. I have been in IT for over 20 years. There is nothing which tests one's own logic as much as a computer. The slightest oversight on your part can cause serious problems. One thing which computers taught me was that small things can have big ramifications. As I thought about the hollow earth idea, it became apparent to me that the slightest oversight by scientists could have a radical effect upon their ideas about the inner earth. Many books have been written about the hollow earth, and the vast majority of them are rubbish. I realized that nobody had applied serious thought to the subject since Marshall Gardner. IT often borrows on ideas and concepts used by engineers. One of these concepts is a feasibility study. I decided to do my own feasibility study on the hollow planet idea to see if it had any merits. My approach was the following. I knew there were many uncomfortable scientific facts which did not fit current theories properly. I wondered if some of these facts could be related to the hollow earth theory. So I set out to find all the facts I could which did not fit current theories, and to see which, if any, could be tied back to the hollow earth theory. I wanted to see if the hollow earth theory could explain some things better than the solid earth theory. The father of the hollow earth theory is none other than Sir Edmund Halley. He was one of the greatest astronomers and scientists of his time. He discovered Halley's comet. He was the first man to propose that the Earth might be hollow. He studied the motion of the Earth's magnetic field. In those days, they did not know much about magnetism. He suggested that maybe there were some magnetized objects moving around inside the Earth, which were causing the Earth's magnetic field to move. He came up with the theory of concentric spheres. He imagined there were several spheres inside the Earth, and each of these was magnetized. He thought they were rotating at different speeds, thereby causing the Earth's magnetic field to move. When there was a great aurora in England, he suggested that it was caused by a luminous atmosphere which was inside the Earth and which was leaking out. He suggested that there was a great hole in the Arctic that led into the interior of the Earth. The hollow earth theory has survived for centuries, egged on by odd people. It is said that Leonhard Euler, the greatest mathematician of all time, also became interested in the idea. He supposedly did not think the idea of several spheres was practical. So he simplified it into a single shell with a large cavity inside it. Euler was a prolific writer, and most of his texts are in Russia. A great deal of his writings have never been translated into English. Sadly, I could not find any of his writings on the hollow earth, even though there are rumors that he played a major role in the development of the idea. Many works of fiction have been written about the hollow earth. The most famous of them is Journey to the Center of the Earth by Jules Verne. Scientists are convinced planets cannot be hollow. This is because of the theory of gravity. In astronomy, the masses of all the planets are relative. So astronomers will tell you that planets are not hollow because when they compare the mass of one planet to another, they find them to have a pretty similar density. Because scientists are convinced the Earth itself is hollow, because scientists are convinced the Earth is solid, they then reach the conclusion that all the planets must be solid. However, if the Earth were hollow, then it would follow that all the planets are hollow. That is an important realization which I came to, that either all the planets are solid or all are hollow. If some were solid and others were hollow, then astronomers would have noticed this a long time ago. You might wonder how come they are convinced the Earth is solid. This comes from the Cavendish balance experiment. The Cavendish balance is a device that measures the attraction between two lead balls. Scientists then take these results and extrapolate them to find the mass of the Earth. This gives them a mass of 6.6 trillion tons. Take note that this is the one and only method we have of estimating the Earth's mass. There is no method of cross-checking these results. The problem with the Cavendish balance experiment is that it is based on a number of assumptions. The lead balls, for example, are electrically neutral. If there is any difference between the planets and those lead balls, then the results of the experiment will be meaningless. For example, the Earth contains electrical currents inside of it up to 1 billion amps. If electricity were to affect the way gravity works, then it would nullify the results of the Cavendish balance experiment. Consider, too, that in nature, static electricity has an attractive force which is incredibly strong compared to gravity. It is assumed that planets are electrically neutral and that static electricity is not a factor to be considered. If any of these assumptions are invalid, then the Cavendish experiment is worthless. In my book, I discuss a great many issues relating to gravity, which we will not go into now. But gravity is not as cut and dried as you may think. There are a great many technical issues to do with gravity that have yet to be solved. Dr. Tom Van Flandern, a professional astronomer in the USA, pointed out that even such things as the speed of gravity are unknown. There is no atomic level theory of gravity which works. We have hardly advanced our knowledge of gravity since Newton's time. One thing I discovered in my feasibility study was that a scientist in the 1960s, Dr. Saxel, mentioned he had a discussion with Albert Einstein. Einstein told him he was convinced that electricity and gravity are interrelated. Dr. Saxel went on to do a number of experiments with electrically charged pendulums to see if Einstein's ideas were correct. He got some very strange results with his electrical pendulums. Nowadays, scientists deny the possibility that electricity may affect gravity. However, if it does, then their estimates of the mass of the Earth will be completely wrong. We know there are electrical currents inside the Earth. Calculations based on the Earth's magnetic field show that deep inside the Earth, there must be electrical currents of up to 1 billion amps. If these currents affect gravity, then the Earth may weigh much more or much less than the Cavendish balance experiment shows. I now want to focus on seismology. I have done something that nobody has ever done before. I dug into the science of seismology to see if it could provide clues as to whether planets could be hollow. What I am about to show you is something which I wish someone would put on a documentary or on a TV program. I feel it is important for people to see this. Let me explain the principles on which seismology is based. Firstly, seismic waves are the main means we have of knowing what lies inside the Earth. Earthquakes generate seismic waves. These waves travel throughout the Earth. The only place we can measure these waves is here on the surface of the Earth. We have instruments which measure the various vertical and horizontal movements of these waves. Seismology is based on the mathematical interpretation of seismic waves. Scientists first create various solid Earth models of what might be inside the Earth, and then they use this to interpret their seismic results. Scientists never consider the possibility that the Earth might be hollow. The Cavendish balance experiment has convinced them completely that the Earth is solid. And so all their analysis of seismic waves is done on the assumption that seismic waves are traveling through a solid planet. The Cavendish balance experiment shows them that a mass of x has an attraction of y. When you drop an object on the surface of the Earth, it falls with an acceleration of 9,8 meters per second. By applying the results of the Cavendish balance experiment, they conclude that the Earth has a mass of 6,6 trillion tons. Their next problem is how to fit this mass inside the Earth, which has a diameter of 7,900 miles. They have found that they have to assume a number of solid spheres exist inside the Earth. As you go deeper, each of these spheres is denser than the one above it. The density of the Earth on the surface is 2,7 times that of water. However, according to the Cavendish balance experiment, the average density of the Earth must be about 5,5 times that of water. Scientists have found a way of fitting this mass inside a sphere the size of the Earth. Over the years, they have come up with a model consisting of 3 spheres. The outermost sphere is the mantle. Then inside it is the outer core, and right at the center of the Earth is the inner core. When they analyze seismic waves, they analyze them in accordance with this model. I wanted to see if a hollow Earth seismic model could make sense. Theoretically, a hollow Earth should not make any seismic sense at all. Let me explain why. Here is a diagram showing the paths of seismic waves through the solid Earth. In the diagram, seismic waves travel from the source of an earthquake, on the left here, through the Earth at various angles, and they reach the other side. If you were to propose that a planet only has a shell with a thickness of 1,000 miles or less, you would have a problem. Seismic waves only travel through solid matter. If there were a giant cavity in the center of the Earth, the waves would not be able to travel through it. They would not be able to reach the other side of the Earth, as you can see there. In this diagram, you can see the seismic ray paths, shown as red lines, moving away from an earthquake source. Note how the huge cavity in this traditional hollow Earth model would block out all the P waves from reaching the other side of the Earth. So clearly, this type of approach does not fit the known scientific facts, and we must discard it. Take a look at this diagram. It shows the ray paths of seismic waves. The key thing you must take note of is that seismic waves travel through every part of the Earth. This is a very important fact to remember. Often when people hear about the hollow Earth theory, the first question they ask me is, where does lava come from? The completely false impression schools have created in everyone's minds is that the Earth is a red-hot ball of lava. They then imagine that lava from volcanoes comes from the center of the Earth. Ask any geologist or seismologist if this is true, and they will tell you it is not so. Standard geology and seismology texts tell a different story. Scientists know that most lava is slightly radioactive, and they believe it is produced either by decaying radium or through stresses in the crust. Lava is created by heat generated within the crust of the Earth. The crust of the Earth is thought to be no more than 20 miles thick, although, to be honest, nobody has ever actually penetrated the crust, so we do not know what lies beneath it. Scientists will tell you that lava is a crustal phenomenon, and all lava comes from no deeper than 20 miles. If the Earth were an ocean of molten lava, then it would actually be subject to tidal pressures, and the continents would be broken to pieces as the Earth rotated. Scientists say the Earth is actually composed of solid rock for the most part. As you go deeper, the pressures are supposed to be so great that the rock actually flows from extreme pressure. But nowhere in modern geology or seismology will you see them saying the Earth is a ball of molten lava. In fact, the final proof comes from seismology itself. When an earthquake occurs, seismic waves travel out in all directions throughout all the Earth. There are two types of seismic waves, P waves and S waves. Based on this, scientists know that all of the Earth is actually quite rigid and composed only of rock. The only partial exception is the outer core. Take a look at the seismic diagram. If the Earth were truly molten, then seismic waves would not be able to travel throughout the Earth. So the fact that seismic waves can travel through and around the Earth shows that it is mostly completely rigid and solid. I wondered if it was possible for a hollow Earth model to make seismic sense. It took me a long time, but eventually I discovered only one model which could work. Here it is. Note how some of the seismic waves travel across to the opposite side of the Earth. I will explain the logic behind each aspect of this model. Let me explain the meaning of the different spheres on this model. Take a look at the right-hand side of the sphere. There you will see a green color near the surface. The outermost sphere is the crust. It is only 20 miles thick. The sphere beneath it is the mantle. Inside it is the outer core, and the white sphere at the center is the inner core. This diagram was generated using a computer program. All I did was assume that the inner core at the center is hollow. As you can see, this model already has the ability to let seismic waves travel from one side of the Earth to the other, bypassing the hollow center and making it appear as if the planet is solid. Let me explain why seismic waves do not travel in straight lines. When a wave travels through matter, which is increasing in density, it will be refracted. If you look at traditional seismic diagrams, you will see the seismic waves always curve away from the dense matter towards matter of lower density. So on a solid Earth model, where density keeps on increasing as you go deeper, the seismic waves will always curve back up to the surface of the planet. I wondered what would happen if deep down density actually began decreasing. Imagine that if you went into the planet, the matter became denser and denser, but halfway down, it suddenly began growing less dense. How would that affect seismic waves? In this diagram, I made the assumption that the density was decreasing between the outer core and the inner core, where this line is. Therefore, any seismic waves which penetrate that far will suddenly be refracted in the opposite direction instead of curving towards the surface of the Earth. They will instead curve in the opposite direction. As you can see, this solves the problem of how seismic waves would travel to the opposite side of a hollow planet. However, if we start making some modifications to this model, then the results become even more interesting. This image is from a university textbook on global seismology. It shows something which is not easy to explain using solid Earth seismology. Approximately 7,000 miles from the epicenter of an earthquake, is a region which receives less seismic waves than any other part of the Earth. This is referred to as the shadow zone. The shadow zone is not completely devoid of seismic waves. Look at the dotted line in the center of the diagram. These are supposed to be the few seismic waves that do manage to get into the shadow zone. This is difficult to explain using the solid Earth model. As you can see in the diagram, they have to assume a rather complicated seismic path to attempt to explain why some waves reach this region. As you can see from that diagram, there should not be any seismic waves reaching that area at all. Now let's go back to my hollow Earth seismic model. I have made some modifications to it. I have changed the size of the different regions. Now look at how well this model fits the facts we know about global seismology. After changing some parameters in my hollow planet seismic model, I have a shadow zone that matches the facts exactly. I made the cavity smaller, and I moved the point of maximum density, which is that line here, I have moved the point of maximum density somewhat lower. Note, the green area near the surface is the shadow zone. Look at the results. We have waves behaving as normal right up to 103 degrees, where the shadow zone begins. Then suddenly there are very few waves inside the shadow area. And then after the shadow zone, there are a greater and greater number of ray paths, eventually converging on the other side of the Earth. This is exactly consistent with the known facts of global seismology. Sometimes small things can make a huge difference. It is obvious from the hollow planet diagram why there should be a shadow zone. This is caused by the gradual change from increasing density to decreasing density. This causes the waves to split over here at this point. Some go down while others go up. This results in an area on the surface which receives less seismic waves than normal, hence the shadow zone. A really crucial point is that the shadow zone is not completely devoid of waves. In the hollow planet model, you can see why this is so. Another fact which also fits well is that the seismic waves tend to converge on the other side of the Earth, opposite the earthquake. You can see this reflected in the diagram as the P waves converge on the other side of the cavity. Let us take another look at a solid Earth seismic model. I now want to discuss in more detail facts we know about seismic waves, which are thought to pass through the core of the Earth, these ones over here. This, no doubt, convinces scientists that the Earth must be solid. However, I want to show you some interesting things about these waves. I now want to show you both the inner and outer cores do not actually exist. There are two kinds of seismic waves. P waves, which are much like sound waves. They are pressure waves caused by a direct push through matter. And then there are S waves, shear waves, which move from side to side rapidly. P waves can travel through everything except a vacuum. It is important to understand that S waves can only be transmitted through rigid materials like rock. It has long been known to scientists that unlike P waves, which can travel around the world, S waves are in fact blocked. They are blocked by something inside the Earth. They named this something the outer core. They decided the outer core had to be non-rigid. If the outer core were a type of liquid, then P waves would not be able to pass through it, but S waves would be. Hence, they invented the idea of the outer core. Very early on, when I became interested in the hollow Earth idea, I realized this property of the outer core, and I wondered if the outer core was a liquid or if it was in reality a cavity. Now let me show you that the outer core does not exist at all, while the inner core is merely the part of the Earth in the immediate vicinity of the cavity. The waves we are interested in are those that pass through the core. These ones here called PKP and PKIKP. The waves which pass through the core are supposed to be going in a straight line. Scientists have realized that these waves slow down for some inexplicable reason. What makes this even more curious is that P waves are supposed to speed up when they pass through dense material. And there is no place on the planet which is as dense as the core. So why do P waves then slow down? According to the formula for the transmission of sound and pressure waves, speed is affected by two factors: density and elasticity. As a rough rule of thumb, if the density increases, then the seismic waves will travel faster. Scientists try to explain the slowing down of the seismic waves by saying that elasticity has changed deep inside the Earth. This is how they manage to avoid the problem. However, the hollow Earth model provides us with a better solution. Take a look at the ray paths of the seismic waves which reached the other side of the Earth. The ones that went beyond the shadow zone. Look at the paths they traveled. They did not travel through the core. They took a longer path around the cavity. They were the waves which traveled near the cavity, hence near the area of lowest density. From this diagram, we can see two reasons why these waves would take longer to reach the other side of the Earth. Firstly, they would not be traveling in a straight line. They would be traveling around a cavity, so they would have a much longer distance to travel. Secondly, remember this model is based on increasing density as you go deeper into the Earth, followed by decreasing density. So the inner part of the Earth would have quite a low density. A low density would cause the waves to also slow down. So both those factors would cause the waves to take a longer time to travel to the other side of the Earth, thereby giving the appearance that they slowed down. So once more, we find a perfect match between the hollow planet seismic model and what we know about global seismology. And as you can see, this explanation accounts for everything we know about global seismology, and we did it without needing either an inner core or an outer core. In order for the solid Earth seismic model to work, one needs to assume that the different parts of the Earth are composed of matter, which varies a great deal in density. But when dealing with the hollow Earth, the opposite is true. In order for hollow Earth seismology to work, one only needs to assume that most of the Earth is composed of pretty much the same material. Hollow Earth seismology will work perfectly well if we assume that most of the Earth is composed of the same rock and matter which we are familiar with here on the surface. If we could prove that much of the Earth is composed of the same material, then that would also be the proof that the Earth is in fact hollow. Look at this diagram. It shows how seismic waves supposedly speed up as they go deeper into the Earth. Notice how those passing through the core do not speed up. You will notice at various depths, such as at 5,000 kilometers, the speed of the waves change very sharply. They either speed up or slow down. Scientists look at these sharp changes in speed and then state that this is due to sharp changes in density. They use this to further prove that the mantle is composed of a different type of material to the outer core or the inner core. You have seen the hollow Earth seismic model and how a seismic ray's path may differ radically from the solid Earth model. Supposing the Earth really is hollow, then it would follow that the paths of waves differ a great deal from what scientific theory supposes. As I showed you with those waves, which are thought to pass through the core, in such a case, scientists may suppose a certain ray speeds up or slows down, when in fact it does nothing of the kind. If they knew the correct paths of the rays going through the core, for example, then it might turn out that such rapid changes in speed never actually occur. However, since scientists are obsessed with the need to have a model which matches the 6 trillion tons needed according to their gravity experiments, they need to find a way of packing lots of matter into the Earth. So they are looking for evidence of changes in density. I'm sure that when they find, they have to account for certain behavior by postulating such instantaneous increases or decreases in speed, that it makes them feel confident that they are on the right track, but the opposite may be true. It is entirely possible that if one knew the exact paths of the rays, then one would find that the seismic wave speeds do not actually vary that much. Let me show you evidence that the Earth deep down is really very similar to the Earth near the surface. Take a look at this diagram. It shows the number of earthquakes which occur at various depths inside the Earth. You will notice along the bottom that earthquakes occur up to a depth of 700 kilometers down. Notice how there are less and less earthquakes up to a depth of 300 kilometers. Then they increase at a depth of 500 to 600 kilometers and finally stop at a depth of 700 kilometers. According to scientists, pressure increases with depth. According to their calculations, the pressure is so great that between 70 and 150 kilometers down, all rock will begin to flow. Below 150 kilometers, there is no known material which will not flow. Therefore, according to scientists, there can be no earthquakes with epicenters deeper than 150 kilometers. But there are tens of thousands of earthquakes that have epicenters deeper than 150 kilometers. The diagram shows us some curious things. Note how earthquakes are occurring at depths below 150 kilometers and in a region where it is theoretically impossible for them to occur. It is these quakes below 150 kilometers that are a mystery to science. These are known as deep quakes. Scientists try to explain these quakes by invoking various possible strange properties of matter, although each theory advanced so far has had a problem with it. What no scientist on Earth is willing to accept is that maybe gravity does not behave the way they believe it does. That diagram may be the proof that gravity does not behave as it is expected at those depths. That diagram may be the clear evidence that the Earth does not have those pressures inside it, and that it remains relatively cool down to those great depths. As a final note, it may be that there are quakes deeper than 700 kilometers, but they are so far away, and maybe the effects of gravity are so weak that they do not have enough force for us to detect them. There are some seismologists who have speculated about the possible existence of silent earthquakes, which are undetectable by modern equipment. And that is hollow earth seismology in a nutshell. I think we have time for questions if anyone is interested in asking.
Yeah, that was fascinating. So what about the classic holes at the poles kind of ideas and stuff? Does that fit with your seismology?
You had to take us there, hey? I was hoping to avoid that one. It is something that I dug into a lot. At various times, I've looked at it from different angles. I started out firstly by just looking for photographs of holes at the poles. And in my book, I have a collection of probably more than 20 photographs that could be interpreted as holes at the poles. And lots of them have probably never been seen by any of you before. I actually spent quite a many months looking for these photographs, trying to find them, trace them back to the original satellite and that sort of thing. In the end, I actually concluded that none of those photographs actually represented a hole at the pole. In each case, there was a real explanation that actually fitted it quite fine. For example, sometimes it was simply cloud formations. I even had a mathematician come and calculate the positions of these features that we saw. But in each case, we could actually pin it to a certain geographical feature. And it's actually amazing how many such photographs are around. But none of them were enough to prove that there is a polar hole. However, what I also did was I dug into Arctic history. And I didn't just do the normal thing of reading about Admiral Byrd or the Nazis or any of that stuff. I actually ignored all of those things. What I did was I read normal polar history and looked into things to see if I could find evidence of something that's not supposed to be there. For example, I had heard that animals had been seen going north for winter, and I had heard that there were islands that had once been on maps and then taken off. And as I dug into Arctic history, I did find some very strange things, and a lot of them centered around a region in the ocean, north of Canada, more to the northwest of Canada, and to the north of Alaska, and it strangely coincides with the region that is where the geomagnetic pole is. And there were lots of mysteries there. There were things to do with land that had been mapped. There was even the suggestion of a continent that existed north of Alaska. And as I dug into the Arctic history, there were some tremendous mysteries that I uncovered. And I would like to actually dig more into this. I have even suggested to people, I wish I could hire an aeroplane or go to certain places and actually conduct certain experiments. For example, there's a place off the northern coast of Canada where you can actually see land which is not supposed to be on a map. And as you saw earlier on in the presentation, Dr. Cook had, for example, photographed a place called Bradley Land. And you see that photograph there, but that place, and he told us exactly where he was at the time he took the photograph. You will not find that place on any map anywhere. And if you look at the Arctic Sea is actually quite shallow. And a strange feature of the Arctic is that it is, for such a large area, it actually has no islands on it whatsoever, even though it is a shallow sea. But take a look at any other ocean on the earth, and you will see islands there. And so I sometimes wondered if there were things that had just been blotted off the map, and the map made to look as if it's just ocean. There are many other things. For example, Admiral Perry, when he was in the north of Greenland, Eskimos told him that volcanic ash had actually fallen on a part of Greenland. And so Admiral Perry then said that judging from the wind currents, this volcanic ash must come from a volcano somewhere far in the north. But nobody ever found such a volcano. And the most interesting thing I discovered, and this actually only happened after my book had been published, was that there had been an expedition in 1914 to a place called Crocker Land. Now, Crocker Land was marked on maps until the 1920s. The US Navy actually sent a very big expedition to Crocker Land, and they couldn't quite reach it, but they did see it. And one of the people on that mission, a Lieutenant Commander Green, actually wrote an article. He actually was a scientist as well. And Green actually wrote an article about the possibility that there was a huge continent to the north of Alaska. And this idea had actually been suggested by one of the US geodetic scientists. He had said that tides to the north of Alaska were weird in the sense that it was as if there was an object in the ocean to the north of Alaska which was interfering with the flow of water. And this was backed up later on by sightings of land by people like Dr. Cook, Admiral Perry, etc. There were actually a lot of people who saw land, and those names are all famous names, and it's all written about in Arctic history. But you will find that none of those things, in the end, they just conclude, oh, there's nothing there. And you'll actually find that the Russians had a similar experience on their side of the Arctic. There were islands which they saw and which they mapped, and which they later on then went and took off maps. One of those places was called Sannikov Land. With regard to the holes at the poles, I dug into ways of trying to prove whether there could be polar holes or not. I could never find a photograph that I believed was genuine. But what I did find was that you could, through other ways, possibly infer the existence of a polar hole. One of the ways was to do with Chernobyl. When there was the nuclear accident at Chernobyl, there was low-lying radiation which moved to the north. Now, one thing which I discovered was that in meteorology, all atmospheric currents move away from the equator to the polar regions. And I actually spoke to an American Air Force colonel who used to go and sort of spy on whether the Russians were actually conducting nuclear tests. And the way that they did it was they would send an aircraft up to the North Pole, and it would collect air samples. And just by picking up air samples from the North Pole, Americans can tell you if the Russians have exploded a nuclear device above ground or not. And so, with the Chernobyl mystery, what happened was, after Chernobyl, there were some American scientists who were at the South Pole, and they were digging in the snow. And they were actually measuring radiation levels. And the snow in Antarctica actually piles up at a very fixed rate. It piles up at 1 foot per year. And because it's so cold there, the ice does not melt. So what happened was these scientists were digging into the snow and using it like the rings on a tree, because by just going deeper and deeper and deeper, you could tell which year the radiation fell. So what happened was they found that at a time that coincided with about 2 years after Chernobyl, that there was a very sharp jump in radiation at the South Pole. And the radiation from Chernobyl has a very particular isotope that does not occur in nature. And so these scientists were actually very surprised to find that there had been an increase in radiation near the South Pole about 2.5 years after Chernobyl. But here's where the mystery came. Scientists know about the flow of air from the equator to the poles. So the way the cycle works is it flows from the equator to the pole, back to the equator, back to the same pole. In other words, the airflow stays in each hemisphere. So air in the northern hemisphere hardly ever reaches the southern hemisphere. And the scientists had found evidence of nuclear radiation all over the northern hemisphere, but they never found any at the southern hemisphere, except at the South Pole. And so that was one of the things I thought could possibly indicate that maybe that air had gone from Chernobyl to the North Pole, gone through the Earth, and reached the South Pole. And the interesting thing was this time delay. And the scientists discovered that there was a time delay of 2.5 years. There was another thing that I also looked into, and that was meteorology. In meteorology, the scientists can only predict weather for a certain time into the future. And all their calculations are finely based. They're done on temperatures and pressures that they've measured throughout a hemisphere. And what scientists have discovered is that their calculations, no matter how hard they try, their calculations are only accurate for a certain period of time. It's 2 or 3 weeks, and I'm sure many of you will question even that. But the only way they got around it was another scientist came along and came up with a thing called chaos theory. And he basically tried to say that maybe it is actually impossible to predict the weather. And he tried to invoke some sort of atomic level ideas, okay? But now the issue is, predicting the weather shouldn't be such a big mystery. It should actually be quite simple. If you know the pressures and you have the formula, you should be able to calculate the results. If you can calculate the results for 2 or 3 days, there's no reason why you can't calculate it for 2 or 3 months or a longer period than that. And the one thing that nobody would ever consider is the possibility that what if the Earth is hollow? What if there is a polar hole? What if there is atmosphere inside the Earth? Because then what would happen is, as the seasons change on the outside of the Earth, you would have air moving into the Earth or out of the Earth, and it would be large quantities of air. And any mathematical calculation you have, if you don't take that into account, the whole calculation will fall apart over a period of time. So those were two of the things that I found that could indirectly indicate there might be a polar hole. There was a third thing, and it has to do with the aurora, and it's very complicated. But I wrote a whole chapter about the aurora, and I even spoke to the leading geophysicist at the University of Alaska about auroras. And he sent me books, and we discussed the issues back and forth for months on end, because it's a very technical subject. But what came of it was that there was a series of experiments that scientists carried out, where the way the aurora is supposed to work is you have charged particles coming from the sun, and they bounce back and forth from the North Pole to the South Pole. So the theory goes. And scientists actually sent aircraft from New Zealand and also from Alaska to different parts of the Earth, and they then injected certain things into the atmosphere and actually measured the movement of these ionized particles from the north to the south. And one of the things they discovered was that there is something that controls the Earth's magnetic field, and that thing creates pulses, and that thing is located at the equator. Now, the center of the Earth would also be at the same level. And there were indications to me that there was radiation that might actually be emanating from inside the Earth. One of the things that they don't tell you, for example, is that when charged particles come from the sun and they create the aurora, when they arrive at the Earth, their speed is so slow that they don't have enough energy to actually create the aurora. And scientists know that there is something, and they don't know what this thing is, but it speeds up the charged particles by 200 times. They have no idea where the energy comes from. And in my book, what I did was I actually tied it to the hollow Earth. And I'm sure some of you have heard of the Van Allen radiation belts. And one of the ideas I just put forward in my book was that if the Earth is hollow, could it be that the radiation is actually circulating not only outside the Earth like a donut, but also through the Earth? And could it be that it's speeding up? And there were a whole lot of things related to nuclear activity, which I also discovered. And one of the people, one scientist that I discovered that I would like everybody to go and take a look at is a guy by the name of Dr. Marvin Herndon, because he's busy working on some nuclear theory to explain the Earth's magnetic field. And this could actually have a very valid application for the hollow Earth and could be part of the proof that the Earth might be hollow. Okay.